Alrighty, we're starting up chapter 6 today, which is about exponential and logarithmic functions. So basically, we're looking at exponentials for the first couple first couple sections, and then we're going to switch over and look at logarithms, which are probably brand new to you. Exponential, you probably have a little bit of understanding of them. So today's key features of exponential functions. During target, I can identify all key features of exponential functions. All right, so the first example we're going to look at is just going into analyzing your kind of just most basic function. Every time we've done a new function this year, this is the approach we take. So let's get into it. So key features, we're going to find domain, range, any intercepts, any asymptotes, and then the end behavior of this exponential function. So first off, an exponential function is anything that's in this format, y equals ab to the x. And a and b are going to be your constants, and x is your variable in this case. All right, so now this one is just 2 to the x. This would be a case where like your a value is 1, like it's just like a 1 out front. Your b value is the 2, and then your x obviously is your x. Okay, so one of the best ways to look at this, I think, just right off the bat as we're starting into it, let's go ahead and just throw it in a graphing calculator. Get a good picture as to what we're looking at here. So obviously you could create a table by hand. You could plug in 1 and 2 and 3 and 4, but this is a little quicker. So from here, if we look at that, we can plot these on the graph. You got 0, 1, 1, 2, 2, 4, 3, 8. And obviously we're going to be off the grid from there. So let's go backwards a little. So at -1, it's at 0.5. At -2, it's at 0.25. At -3, we're at 0.125. And what you notice here is as you keep going, these keep getting really, really close to 0, but not ever reaching there. So what we get here is this type of idea, like so. So that's what our graph looks like. Okay, so let's see if we can answer all these different things. So domain. What x's does this cover? Well, this looks like it goes left forever, and this looks like it would go right forever. There's no fraction at all, so this has no restricted values. This is just all real numbers. Again, you could say negative infinity to positive infinity if you wanted to. A lot of ways you can write the domain. The range. Okay. So the y values, this does stop. This never gets below 0, no matter what. Because as you keep putting negative numbers into here, this just keeps getting closer and closer to 0, but never hitting it. So basically, you can go up forever, though. So we would word this as the y value has to be greater than 0. Can't be below 0. It's basically, it can't equal 0 either. It approaches it, but never touches it going that way. Intercepts. Only 1. The only spot the graph crosses is right here at 1. So we would say it has a y-intercept at 1. That should be the coordinate 0, 1. What's interesting about this and what you're going to start to notice is it's this a value. So if you want to make a little note there, in our problem, our a value was 1. You're going to notice that pretty much holds true. So we'll see some more of those as we go. All right, asymptotes. Should remember this from Unit 4. A line that the graph approaches but never touches is your x-axis here. We want to give it as its coordinate, as its equation. That would be y equals 0. Remember, horizontal lines are always y equals, vertical lines are always x equals. And lastly, the end behavior. End behavior is one of those things you can word a few different ways. The way that you're going to see it, like in the assignment today, is you're basically going to say, as x goes to infinity, what does y do? And then they're going to say, as x goes to negative infinity, what does y do? So as you go off to infinity this way, the y value also goes up to infinity. Okay, x goes up, the y goes up forever. As x goes to negative infinity, though, your y value approaches 0. Okay, so that's just describing what happens as you go left and right forever. All right. Now we should be able to do this exact same thing for the next graph. What you're going to notice, though, is this graph happens to be exponential growth, where it's increasing as you go left to right. You're going to notice this one is it's the opposite. It's decay, which we'll talk more about in a couple days. But anyway, let's go ahead and get to it. So same thing, we're going to type it in. We have the 5 times 1/2 to the x. We graph it. You're going to see this one comes up and levels off in this direction. Kind of looks sort of like a mirror image in a way. But let's do the same thing. We'll get some points plotted. So let's start with -1, 10, and 0, 5, 1, 2.5, 2 and 1.25. At 3, it's at 0.6. And you can see it's going to kind of level off towards 0, just like our other one did. So we're going to get this kind of deal, like so. Okay. And same questions. We'll run through them. Domain. Left and right forever, so all real numbers. Range. It's actually pretty simple. Or sorry, pretty similar. Once again, the lowest this ever hits is it doesn't quite hit 0, but it does go up forever. So it's actually the same range. Y is greater than 0. Intercepts. Once again, only the 1, and it happens to be at 5, which is this A value. So keep in mind that always is going to match up with whatever that A value is going to be where the Y-intercept is located. And then in this case, there is no X-intercept. Asymptote is the same as the last problem. Once again, Y equals 0. And lastly, our end behavior, which you can probably notice here, is it's going to be flip-flop from the previous one because it's doing the opposite thing. As X goes to infinity, your Y is approaching 0. So as X goes to infinity, Y goes to 0. And as X goes to negative infinity, Y goes to infinity. Okay, so all the same questions for a decay type of graph here. All right, let's go ahead and last thing we're going to look at today are transformations. And this we've also done every time we've started a new function. We've done the same exact type of concept. So it says graph each function, describe the graph in terms of transformations of the parent function 3 to the x. So 3 to the x is the base function in this case, which is a lot like 2 to the x that we just graphed a second ago, but just a little bit steeper basically. So 3 to the x, boom, looks like this. So now they're saying, what's it going to do to like your asymptote, your intercept? How's it going to change things from the parent function? So let's go ahead and do this. Let's just do exactly what it says. So it's a -3 to the x, and we graph it. And what you see is it is, as we've seen many times, just a complete reflection over the x-axis. So this is going to be reflected over x-axis. And that shouldn't be new to you. We've seen the negative do that every time in quadratics and rationals and cubics and every function we've ever looked at. So nothing new there. How does that affect the asymptote? It actually doesn't. Still approaches 0. So no change to the asymptote. How does it change the intercept? It's going to make it the opposite. So this intercept was at, I believe, 1. Yeah, and then it flips down to -1. So, and then for the y-intercept, we'll say it goes from 1 to -1. Okay? All right, so that covers everything asked there. So now we jump to this one. This -4. Hopefully you're thinking, you're like, oh, we've seen this before. This just shifts the graph down 4. Let's make sure it does. So if we take the exact same function, throw a -4 on there, and let's see, does it look the same shifted down 4? So there is our original graph. Boom, coming in there. Looks like it shifted down 4. So yes, so we've seen this before. It's going to just go down 4. What does that do to our asymptote? It also shifts it down 4. So instead of being at 0, it's at -4. And what does that do to the y-intercept? Also shifts it down 4. So it was at 1. Now it's at -3. Okay, and so it all makes sense. If you're shifting the graph down 4, it's going to shift the asymptote and the y-intercept also down 4. All right, here's a couple other little follow-ups here. If you want to try to answer these on your own, I'll go through and answer them in a sec. Alrighty, so for the first one here, I put in 5 to the x, and I put in 5 to the x plus 3. 5 to the x was here. The x plus 3, again, anytime you directly affect the x causes left to right shift, in this case, left 3. So it did no change to the asymptote. You can see it still just approaches y equals 0 there. And then it does quite a number on the y-intercept. And so I actually just looked it up in the table. So it was originally at 1, and now it's at 125. Because when you're shifting one of these exponential graphs over, they spike really quickly. So this y-intercept that was here, when it gets shifted over, now it's crossing somewhere way up high. So that's why you'll get a pretty big jump there. Okay, and then for the second one here, same concept, except now they want us to do negative x here. Okay, so what does that do to us? Here's our original. And there's our other one. So this, we've actually not seen in a long time. This is going to cause a y-axis reflection. We saw this like week 1 of this class, and it really hasn't come up much because it really hasn't applied to anything we've been doing. But it is a thing. So again, talking asymptotes, no change, still y equals 0. So still same thing, no change. And then talking the y-intercept, crossed at 1, looks like it still crosses at 1. We can verify it here. Yep, still no change. So it's just 1. Okay. All right, so you got introduced to exponential functions. We got our transformation type stuff that we've seen before. You have some questions on these today?